Good day viewers, welcome back to my channel. Today we have the following interesting definite integral problem. Okay, here we have integral as x goes from 0 to 1, the inverse sine of x dx. This equals that. Okay, please, if you have not subscribed to my channel, please subscribe, comment, share and like the video. Thank you. Now we're going to start by making a substitution. Okay, so I will say let the inverse sine of x equals y. Okay, here we can see that x is equal to the sine of y. Now differentiating both sides, so we get the x is equal to, the derivative of sine of y is equal to the cosine of y dy. Okay, now if I let our integral equals I, okay, so here we get I is equal to integral. Okay, now let us know our new limits. Okay, so recall from here, y is equal to the sine inverse of x. So if x is approaching 0, y will be approaching the sine inverse of 0, and this is equal to 0. Okay, so this is our lower limit. Now upper limit here is 1. So here, if x is approaching 1, y will be approaching the sine inverse of 1, and this is equal to pi all over 2. Okay, so here our upper limit is pi all over 2. Now here, recall that the sine inverse of x is equal to y, so we'll be replacing this with y here. Now what is our dx? Our dx is equal to cosine of y dy. Okay, so here we have the cosine of y dy. Okay, so now the next techniques we'll be using here is the so-called integration by parts. Okay, so we have integration by parts. Okay, now let's see how this technique is going to work out. Okay, so here we always let u equals y. So now the derivative of u here will be dy, that is differentiating both sides, so we get du is equal to dy. Now here, what is going to be our v? Okay, should our v be the cosine of y here? No, our v is going to be the integral of cosine y. What is going to give us? So if you integrate cosine y, recall that we're going to get the sine function of y. So here we get dv, derivative of sine of y will give us that cosine of y dy, which is here already. So our v will always be the integral of this function here, so that when we derive it, we get this function back. Okay, so now recall that our I here is going to be uv minus integral of v du. Okay, so now replacing this, so we get our u here is y. Okay, our v here is sine of y. Now recall our limit from 0 to pi all over 2. Okay, so minus integral, recall our limit from 0 to pi all over 2. So what is v? What is v? So v is sine of y. So sine of y. And what is our du? Du here is equal to dy. Okay, so our du is equal to dy. So from here we get I is equal to, inserting the limits here. So first of all, we have the upper limit. So here we have pi over 2y, then sine of pi over 2 minus the lower limit 0 times sine of 0. So this is what we have here. So minus, remember the integral of sine of y is going to give us, so let us put in bracket, negative cos of y. Now our limit is from 0 to pi all over 2, so we close this bracket. So the next thing is simplification from here. Okay, so here we have I is equal to, here pi all over 2, sine of pi over 2 is 1, so we get pi over 2 minus, here 0 times everything here is 0, so minus, now inserting the limit, so first of all, we have negative cos of pi over 2. Now minus, open bracket, minus cos of 0. That is the lower limit. So simplifying here, so we get I is equal to here pi over 2 minus, in bracket, cos of pi over 2, cosine of pi over 2 is 0. So we get 0 is neither negative nor positive. So we actually get 0 here. Then minus, in bracket, here we have cos of 0 is 1 and we have negative 1. So negative times negative, so we get plus 1 here. So here we get pi over 2 minus 1. And this is the right answer to the problem. Thank you for viewing, and please make sure you subscribe to my YouTube channel for more interesting videos.